Hey everybody, Mr. Piercy here with some practice problems on the distance formula. So this is how we're going to be working the distance formula. Now, if you have a calculator, you can definitely use a calculator at some point, but I'm going to go ahead and show all of the steps from start to finish of how you would work a problem like this out. Now, at some point, you probably will want a calculator for some things, depending on how your questions are asking you to give you the answers. And I'll explain that when we get there. But say we have these 3 points, or these 3 line segments. I probably could have called them things besides A and B, but I'm not feeling very creative right now as far as coming up with different points. So I'm going to just call them all AB. And we want to know what are the lengths of these 3 segments. Now, the distance formula, as we showed in the investigation where the distance formula came from, it's just another way of rewriting the Pythagorean theorem. It is the difference of the x numbers squared and the difference of the y numbers squared. And anytime, again, you use a formula, I consider it good practice. If you're going to use a formula, you're going to write it down. So we want to know what is the length of all of these segments. Now, for the purposes of these, I'm going to say that A's I'm going to say that A's are 0.1, so B's Now, again, this is kind of arbitrary. I could do it the other way around. I'm going to just kind of do it this way just to keep things consistent and showing you how essentially all you're doing is just substituting values into a formula and simplifying it. So x2 minus x1, the way I've chosen to do it is I'm going to say 5 minus 1, the x-coordinates of B and A. And then we'll take the difference of the y-coordinates of B and A, so I'm going to say 4 minus 2, and I'm going to square that. Now, doing your order of operations, you combine your like terms inside of the parentheses. So 5 minus 1 is going to give me 4. And in the other parentheses, 4 minus 2 is going to give me 2. And now we can square those. And I'll get 16. Oops, I forgot to square it here. Plus 4, which gives me the square root of 20. Now, that can be simplified with 2 factors, the square root of 4 and the square root of 5, which would simplify to be 2 radical 5 as an exact answer. Now, 2 radical 5 is the exact answer. If you wanted to, depending on what your answer or what your question was asking you to do, say you wanted to round it to the nearest, I don't know, 10th, okay? No, let's say the nearest thousandth. So the nearest thousandths would be 3 decimal places. So if you say 2 radical 5 or the square root of 20 on your calculators, this is really the only thing we really need a calculator for. We would say it's about 4.472. So those would be 2 answers that we could expect to see for that problem. The radical answer is considered exact because we're not rounding. And of course, the rounded answer, no matter how well we did our math, is going to be considered an approximate answer because we had to round it at some point. So let's try doing the second example here. Once you get a couple of these under your belt, you're going to realize, oh, well, it's pretty much the same thing over and over and over again. So x2 minus x1 squared and y1 minus y2 squared. So substituting the values, again, I'm going to look at b as 0.2, so I'm going to say 2 minus negative 3. So 2 minus negative 3 squared. And then I'll say 3 minus 5 for the y's. Do your order of operations. Inside of the parentheses, 2 minus negative 3 is going to give me 5. And in the other parentheses, we're going to get 3 minus 5, which will give me a negative 2. Now remember, when you square a negative number, you're basically saying a negative number multiplied by itself. So anytime you square a negative number, you should get a positive answer. Once you get past this point right here, you shouldn't see any negative numbers in your problem ever. If you do, you squared your numbers wrong on your calculator, you squared it wrong on in your head, something. So 5 squared is going to give me 25, and negative 2 squared is going to give me a positive 4. So that simplifies to be the square root of 29. Now the square root of 29 can't be simplified as a radical. It doesn't have any perfect square factors. So the square root of 29 would be the exact answer. And the approximate answer, again rounding it out to 3 decimal places, would be about 5 point, oops, I can't read my calculator here, 5.385. So there is our exact answer and our approximate answer for problem 2. So now let's take a look at the third one here. And if you're probably, once you've seen these two, you're probably ready to just race ahead of me now. But I'm going to go ahead and finish what I started. So start by writing the formula. X2 minus x1 squared. Y2 minus y1 squared. And a lot of kids ask, do you actually write the formula every time you write it? And the answer is absolutely. If I'm working out a key, or if I'm working a homework assignment, or if I'm just practicing something on my own, if I use a formula, I always write the formula down and then go back and substitute it, because I am human. I do make mistakes, and sometimes I need to just go back and take a look, and sometimes, oh, you just wrote the formula down wrong, and then you can go back and fix your mistake, something. So here, the difference of the x's, keeping b the second point and a the first point, I'm going to say 3 minus negative 1, and I'm going to square that. And then I'm going to say negative 2 minus 2, and I'm going to square that. Inside the first set of parentheses, 3 minus negative 1 is going to give me a positive 4. And negative 2 minus 2 is going to give me a negative 4 here. Well, positive 4 squared is 16, and negative 4 squared is also 16. And the square root of 16, or 16 plus 16, is going to give me the square root of 32. Now, the fact that I have two 16s going on here, that's a nice thing for me to help me simplify it. The largest perfect square of 32 is the number 16. So the square root of 16 is going to give me 4 radical 2 as my exact answer. Or as an approximate answer, oops, it would help if I typed the right thing into the calculator, 4 radical 2, about 5.657 units long. So there we go. Those are 3 examples of how we use the distance formula to substitute numbers into the problem, and just use your normal order of operations to simplify it. And again, just kind of pay attention to your directions, how you're asked to simplify your answer, whether you leave it as a simplified radical or round it to a particular decimal value. And it really doesn't get any more complicated than that. I mean, it looks complicated, but it's really not. It's just substitute some numbers and do your order of operations and see what you get. So if you have any questions, make sure you let me know, and I'll be happy to work with you on anything that you might be unfamiliar with. And until next time, guys, thanks for watching, and be good. Take care of yourselves. See you later.